All right, let's get this show on the road. I'm going to start this off a little bit earlier. But, all right. Let's make sure it hits on my phone. Hope you're doing well. If you were in the United States, if you're a United States citizen, happy 4th of July. And we're going to jump right into this. We're talking about Ethernet on Zephyr. And I'll just show you how to configure it, set it up, a couple gotchas, and also some things to think about if you're doing your own Ethernet implementation. Cool, over on the phone. So we'll be jumping right in. Oh no. There we go. If you haven't already, please hit that subscribe button, that like button. Let me know in the comments things that you'd like to see covered here on these live sessions. I do these live sessions every week. So if you have something that is burning your, is really bothering you, maybe something that you've been working on or something that you need help with in Zephyr, maybe a specific part of it, please leave a comment. Let me know, because a lot of these live sessions are community generated. They're suggestions from the community, so it's all about you, and I'm going to keep that theme going. So, and this week is something that I've been dealing with personally, is getting Ethernet working, and also some other summer aspects of that. So we'll be talking more about it. And if another ask, if you are not subscribed to my mailing list, you can check it out. jaredwolf.com. It's right there on the homepage, and you can subscribe there, and you get kind of the updates. And I'll send out an email usually about an hour before these live sessions, so make sure you're subscribed there as well. Looks like we already comments. Hey Franz, good to see you. Hope you're enjoying your European summer. Maybe some time off, hopefully. All right, we're gonna jump in. So, Ethernet. Switch it over. So, advantages, it's great because it's reliable. That speed and the latency is very low. So, from a communication standpoint, like, this is the gold standard. This is something that you can rely on, something you don't have to worry about too much. No cellular, nothing's going over there. Everything's connected via wire. The disadvantages is that you need that hard connection point. The cable line and the Ethernet drop and the power and all that other things. That stuff adds up, and you also have to have it there. So, for applications where you might have it out in the field, where you want it to be connecting over cellular, or out in the field where you don't want to run wires, this is not the solution for you. But what I found is I was using a solution where I was using the NRF9160 Feather actually, and what I found out is the particular location that I wanted to use it in did not have really great cell signal. So the solution was, okay, let me see what other options there are. Either I can connect via Wi-Fi, so a Wi-Fi solution, or connect via a Ethernet drop. And it turned out that they had some Ethernet drops already at the location. It was easy to repurpose them, hook up to a switch where everything that I was doing is kind of cordoned off in its own little VLAN world. And it just worked a lot better compared to a cellular solution. So you're going to run into those situations, especially if you're deploying any type of IoT device. So the nice thing about Zephyr is that the pivot to Ethernet was, while the Ethernet part was easy, the other parts were a little bit harder, and I'll kind of allude to that. I'm alluding to something I'll be talking about in a little bit, but it's just the cool thing is, like, I didn't have to touch 90% of my code. And this is what I talked about at the Zephyr conference this year, Zephyr Development Summit, is talking about, hey, I have this one central piece of code. How do I get it to work on a different processor, maybe with a different backend or a network interface, things like that. So it's just that's the power of Zephyr. That's really cool, that you can just like take this code that's written for one device and port it over to another device. In this case, it was the NRF91. I was porting it to the NRF52 with this particular Ethernet device. So we'll jump in there. So I just threw it on one of these particle Ethernet feather wings. If you get a little backpack, it can be power over Ethernet capable, and it uses the WISNet W5500. which is supported in Zephyr, which is great. And you can get this guy on DigiKey or directly from Particle. I think it's a little bit more expensive from Particle, but they're out there and they're useful. And then you can also get the chip itself. You can see here, like, this thing's only a $2 chip, which is crazy. So you can roll your own designs. If you feel like rolling your own, throw an Ethernet connector. You know, you can look at all these other open source designs and see how to do it yourself, and then roll your own. It's in the end, you're probably going to save money compared to just buying something like a Particle one. So the configuration. So you've installed it. You have it there. Actually, I'll pull this one off. I'll just show you guys real quick. So this is my modified hub. You can see. So it's got the Ethernet board and then a NRF52 based Particle Xenon, which is running Zephyr, of course, and then I have a 7-segment display for displaying things. So I had a different enclosure, which basically was fitting the very similar components, but I just adopted it to have a little Ethernet buddy. So jumping into the configuration, literally it runs over SPI, so it's pretty easy. You make sure that the SPI bus is activated, and also you're enabling that driver for the Ethernet. And then there's a whole bunch of networking stuff that happens on the back end. If it's not already turned on, you got to make sure you have that layer 2 Ethernet turned on. And for instance, like I think the shell may be turned on by default, and I just turn that shell off. Make sure sockets. Depending on your needs and your application, you might need IPv4, IPv6, TCP, ERP, UDP, blah, blah, blah. So this is all dependent on your applications, and it's all application specific. The more you have turned on, the more space it's going to take. The less you have turned on, then you are very application focused specific, and that's what we're trying to do here. I could have turned off, like for instance, UDP, ARP, things like that are not really necessary, but this will get you the core functionality. And importantly, for the most part, in any type of Ethernet setup, you're going to be using DHCP. So that is for getting your device to get an IP address. So and that is something we'll be using here. So, but like I said, depends on your project needs. And for instance, MQTT utilizes TCP versus co-op uses UDP. So if you're using a specific protocol, you can turn off the one that you're actually not using, and it'll save you some space. So, and of course, overlay time. You can see that I've set up the SPI bus on that NR52. You can see these pin numbers. They go above 32, which means that they're on port 1 versus port 0. And this is using since version 2 of NRF Connect SDK, they've changed how the pins are configured. So this is the quote-unquote the old way to do it. And that's just something to keep in mind. It might look different if you're using a newer version of Zephyr or newer version of NRF Connect SDK. And yeah, if you have a Xenon, it maps right to this. If you're using something else, you're going to have to modify it to match all the pinouts. And those pinouts are what the pinouts match the pins on the Particle Xenon or the Particle Ethernet featherwing. If you're using a different featherwing, you're going to have different configurations. So just bear that in mind. Just something to keep in mind. Here's the C code. It's pretty straightforward. One thing that they add, so some people don't even do the, for instance, Goliath had some examples on their SDK of adding Ethernet, and they don't even set up these management callbacks. I just set them up so I can get a callback when the address was actually generated by DHCP. It's kind of convenient versus you have to pull or check something. It'll just generate that callback whenever that address is added. So the first two calls are literally just creating that callback. Next is getting a default device that's on Zephyr. So if you set up the driver, hey, I have an Ethernet device, it's just going to get that default device, whatever's in Zephyr, that's whatever's been registered. You might have to do some trickery if you have multiple different interfaces. I haven't gotten there yet, but I'm sure there will be some type of thing you have to do where you have to choose which one, or maybe look up and see which one it is. but in this case I'm just using the default. And then the network and starting the DHCP. So we're just starting the DHCP process to get an IP address. And the biggest thing here is like getting that, once the lease is acquired, that DHCP lease, we just get the callback event, and that will, I'm just using that as a event to propagate to my main function where I'm actually doing the connect disconnect from the back end. So it looks like Franz has a question. I'll throw it up. So the question is, would it be possible to make some routing between a socket over Ethernet and the cellular connection, some kind of basic routing? That's a good question, actually. There's a lot of those type of situations in IoT where, for instance, a great one that I know is being worked on right now, but it's not done, is OpenThread, where right now you can't really have an OpenThread border router on like an NR52, even though Particle pretty much kind of did that. The idea is like you somehow pipe things down and through and into a different interface. I haven't played with actually like having you like cooking up the NRF91 and using it as like a pass-through to an Ethernet powered device. I've not tried that. That's like almost the pseudo like a network router type thing. I'm sure it's possible with Zephyr, but I haven't gotten that far into it. So I'd be curious if there is a solution out there. But a lot of it's just wiring up the different components and getting things to work. I don't know if you can even host a DHCP server on the device if you did something like that. So that's my guess, and I'm saying it's possible, but I don't know if it exists yet. So this code, kind of small, bit of an eye chart. You can kind of see what's going on here. The handler just gets set up and then it's just filtering out the events, and it's just making sure the address that the address event that actually happened was actually caused from DHCP. And then all I'm doing is creating the app event manager, using that guy to push the Ethernet ready event to my main context, so I can actually know that, hey, an IP address has been registered to this interface and we're good to go. We can start doing things. Next. So yeah, we're triggering events. We're using it to trigger the events in code. So where that callback is used to like send events, maybe connect to a backend, send an electronic smoke signal. Who knows? It's all up to you, and it's all to your application. So this is just a basic example of like how to, hey, got a DHCP address, it's ready, you can be connected, you can start an MQTT client, you can start a co-op client, you can do whatever you want to do. HTTP, like the world is your oyster. You can do what you want here. So adding Ethernet to an already existing application, from my point of view, was really easy. So that was the easy part. The hard part was actually adopting, especially for any TLS, DTLS, you have to configure embed TLS manually, and you have to make sure those settings that you have set up are compatible with whatever device or backend you have it communicating with. So for me, I ran into a bunch of problems where I didn't need to make sure the cipher was correct. I need to make sure that I was using the right type of cryptography. So originally, or by default, embed TLS turns on RSA and leaves everything else off. I wasn't using RSA, I was actually using EC to for those, the keys that I generated were all EC, so I need to turn that on and turn off RSA. And it's just a matter of like turning on all the flags and having everything configured properly for it to actually connect. So that's, maybe I'll do a separate live stream on embedded TLS and just show how I configured mine to work the way I expected it to. It was a long process. Actually, I happened to be doing that over the weekend because I had to get some emergency stuff done. But yeah, it's just not expected. The Ethernet stuff was so easy, and then getting to the part where I had to communicate securely was another box of worms altogether. Can of worms, box of worms, same thing. So another kind of caveat is it was a little bit more complicated. Maybe you're using embed TLS in a different way. Maybe you're using it for a different network interface, and you don't have something where the TLS implementation is like built in. It's actually you're using embed TLS. Your situation might be easier. For my situation, I was going from the NRF91 where I was using the onboard TLS implementation in the modem firmware versus using embed TLS. So I had to switch over to a completely different implementation where a lot of the work and the hard stuff was done for me on the NRF91 versus NRF52. So that's just like one thing you got to keep in mind is like what was my platform capable of, and then if I'm switching to something else, like what am I getting myself into? So it's a little more complicated, but in the end, it works. So that's kind of cool. And that's it. But we can go into some questions. I know, Franz, you have more questions. Yeah, I couldn't. Going back to where we were talking about the routing setup, I couldn't figure out yet, but didn't spend too much time on it. But we'll try to keep it. So he'll keep me posted. Cool. And then how much RAM consumption with the Ethernet adapter typically consume a lot of memory? Yeah, that's a good question. I actually configured a lot of more memory usage for embed TLS and for some of the other things I was doing. Like I was actually, one of the more complicated parts of setting this up was, which is all related to embed, was that I was setting up the secure certificate storage. So I was using the USB CDC, so using USB, what I just covered in the last session, but setting up a USB emulated serial interface, and I'm sending certificates over that interface, and I actually had to create, increase the buffers for that. So the shell buffer and the USB buffer, and making sure those are a large enough size, so when I'm sending over 1,000, 2,000 bytes at a time, it's not going to croak. So those are the things I had to increase. I actually haven't done any profiling to see how much memory we really was using on my NRF52. I know it's probably a lot more compared to maybe another solution, but the nice thing about Zephyr is just it works. So the only other setting that I did have to tweak on the WizNet was, and that's one thing I didn't show here because I was looking at another sample, but I'm just making sure that I'm setting up the socket timeout configuration. So in that configuration, I actually did not have the socket timeout stuff. I figured that out after I created this presentation. So having that in place, and then there is a timeout setting for the WizNet Ethernet driver, but I haven't, beyond those settings, I have not looked into the implications on the platform. I didn't change the stack size or the heap size, so, or the system work queue size. So just to give you an idea of like if there was any issues with stack overflows and things like that. All that stuff stayed the same. Let me see. Was there anything else that I changed on there? I have it open in the background here. Yeah, I didn't modify any stack. The only thing I modified was the heap size for embed TLS, because some of them were a little bit bigger. Ring buffer size, yeah, and and the log buffer size. So when I was debugging all this embed TLS stuff, I had to increase the string duplication buffer, and then also the buffer for the log. So those are other things I had to do, but besides that, there weren't any big implications on the application for this particular setup. Maybe if you're using a processor that's maybe not more network oriented. I know the NRF52840 is pretty well equipped. It's got 1 meg of onboard embedded flash, and then I forget how much RAM, but maybe we'd run into issues if we're using the NRF52832 or something smaller. So let me see. Oh, lost my chat box. But yeah, hopefully this has provided some insight for your IoT adventures in Zephyr with Ethernet, getting that up and running. Like I said, if you're trying to just do something basic Ethernet without any crazy encryption, you might be okay. But if you start adding some encryption to the mix, you might be running into some interesting things. So thanks for coming out today. Really appreciate it. And wishing you all a happy and productive week. Folks in the United States getting back to work. So it's time. It's time for me to get back to work. So Franz, thanks for being here. Thank you everyone else for being here. And we'll see you next week on the next live session. If you have ideas throughout the week, please leave them in the comments below. Let me know, and I'll try to get a session together on that particular topic. So that's it for now.